All right, so yesterday, so we have talked about the derivatives of exponential functions. Okay, so we have only two ways of deriving exponential functions. So the first one is when we have e raised to u, and then u is a function of x. So we just uh, write this thing again here, and then we get the derivative of the exponent or the value of u, or whatever expression here. Okay, and then for the second one, okay, it's basically the same thing as the first one. It's just that it made it simpler. Okay, so for if e is raised to an expression ax plus b, wherein uh, a and b are constants, so it's a linear one most of the time. So this coefficient here will be multiplied in front of the, okay, in front of the letter e or e. So that's why we have a here. And then we just write the expression again, ax plus b. So we had this yesterday. So let's just recall. Okay, so again, if you have, let's say, e raised to 5 minus 2x, so look at the coefficient of x, which is negative 2. And then that negative 2 will be multiplied to e. That's why you have negative 2 here. And then just copy this part here, and then that's it. Okay, so that's the shortcut of that. If you don't want to do this, you can straight away do that here. Okay. However, for letter B, since this is not a linear, this is a quadratic, we cannot apply what we did on letter A. So basically, we just need to write this again, and then we get the derivative of x squared plus 1. And then, so simplifying this, we get 2x. So this 2x times e raised to x squared plus 1 is this one. Okay. All right. So anyway, let's move on now, because I cannot discuss everything that we had yesterday because it will take up too much of our time. Okay. So again, how do we graph exponential equations? Or maybe how do we answer questions like these? Okay. So okay, so let's draw the graph of y is equal to e raised to 1/2 of x for 0 until 2. Okay, for the x values starting from 0 to 2. Taking intervals of 0.5, and then by drawing a straight line, y equals 3 minus 2x on the same graph, obtain an approximate solution to the equation of the two. Okay, so basically, how did we draw this graph again? This curve, okay, by using 0, 1, and 2 as our x values from here, class. Okay, so 0, 1, and 2. And then getting the y values, we just need to plug the x value in place of x here. Okay, so we got 1, 1.65, and 2.72. So plotting those, so we have 0, 1 is here, 1 and 1.65 is over here, and then 2 and 2.72 is over here. And then by drawing a curve, okay, yeah, so this is part of your curve. Okay, and then how did we draw the straight line? Y is equal to 3 minus 2x. So same, we plug 0, 1, and 2 in place of x here. So that's why we have this point, and then we have another one here. But then, of course, it creates a straight line. So our solution here, or the approximate of our solution here, is their intersection point. So in here, so your answer here is approximately 0.75. So that's your answer for this kind of question. Now let's have one more graphing question. Okay, so let's have this one. Okay, so draw the graph of y is equal to e raised to 2x for uh, x values starting from 0 to 2, taking intervals of 0.5. It's similar with the previous question. It's just that your equation or your function is different now. It's 2x. And then we need to draw another line, another straight line, with the equation y is equal to 5 minus 2x on the same graph. Obtain an approximate solution to the equation of e raised to 2x equals 5 minus 2x. So how did I draw this blue line here? Okay, so this is part of a graph. It's like this. Okay, so it's, how did I draw the blue or the blue curve? Okay, wait, let me put this on the side here. Okay, now if you have observed, look at the blue curve here. Now these are the values for my curve. Okay, so we are going to use values 0, 1, and 2 stated in the question. So 0, 1, and 2. So we just plug this in place of x. That's why 0 and 1. That's my first point. It's here. Okay. And then if I plug 1, my answer is 7.39. So this is 1. Okay. And then this is 7.39. All right. So it's about here. Okay. It's above the line. Okay. And then I have x is 2, and then y is 54.6. So here, because my graph is too small to put 54.6, so I just assume it's way over there. Okay. Now you don't have to put that here. Okay, because our main concern here is to see their intersection between the curve and the line. Okay, so if you cannot, if it's too big, you don't have to show it. Okay, you just need to show their intersection point. All right, how about the line? So again, the line, we use 0, 1, and 2 as our x values. Then plugging those in place of our x in our linear equation, so we get 0 and 5. That's why you have 0 and 5 here. Okay, and then if you plug 1, you get 3. So that's why you have a point here. If you plug 2, you get 1. That's why your other point is here. And then drawing a straight line. So what do you think is our answer here? So our answer here is this. Okay, this one. Okay. Okay, wait, let me remove this. Okay, but then let's trace. Let's try to approximate the location of the point. Okay. Okay, so what do you think is the value of that? Hmm? So if I would approximate that, so therefore, the approximate solution to e raised to 2x equals 5 minus 2x is, what do you think is this one? So I think, so if this is 0.5 and this is 0.1, so this is 0.6, 0.7, right? Okay, so 6. Okay, so I'm assuming this is 0.6. Okay, so let's approximate that. That is 0.6. So your answer is 0.6. Okay. Uh, so do you have any question, class, on how we graph exponential equations? Hmm? No question? All right, so let's have some word problems, other word problems. This is my last example for graphing. Okay. All right, now can you please go to page 412, 412. Okay, so let's go to page 412, and then let's do number 6. Okay, number 6. Please get a pen and a paper. Okay, let's solve number 6. All right, so let's have this question. So given that y is equal to 2x, sorry, 2 raised to x plus 1, let's find the value of y when x is 0, and then the value of x when y is equal to 8. Okay, so how do we answer this kind of questions? Okay, so for letter A, what is the value of y when x is 0? So basically, we just write the equation again. Y is equal to 2 raised to x plus 1. So y is equal to 2, so 0 plus 1. So basically, y is equal to uh, 2, right? Okay, that's just that. Okay, and then how about for letter B? What is the value of x when y is 8? So writing the equation again, y is equal to 2 raised to x plus 1. Okay, so what do you think is the value of x when y is 8? So if y becomes 8 equals 2 raised to x plus 1. Now, what do we do here, class? Please help me on this one. Okay. So how do we solve for x? What do we do next? By the way, question, where is our x? It's in the exponent, right? It's here. It's an index. So what do we do? How do we solve for this x if it's here? It's like for any idea, any anything that that you remember on how to solve this kind of questions, because this may pop up in your test. Anyone? What should I do? How do I solve this question here? This equation. All right. So I think you need some. Okay. All right. So let me remind you guys. All right. Let's do this now. All right. So when your variable is here on top, it's an exponent or an index. All right, how do we solve for this kind of question? Observe your base or your bases. Your base here is 2. Your base here is 8. So class, again, if the base are equal, the exponents or the indices are also equal. So is there a way that I can rewrite 8 and make it base 2? Anyone?
Yeah.
All right, so this is 2 cube, right? Equals
Yeah.
2x plus 1. So again, if the base are equal, that means your indices are also equal. So with that, so we have 3 equals to x plus 1. So therefore, x is equal to 2. All right, so you remember now? You recall this topic now? Okay, so that is letter B. And then, for the last question, hence, sketch the graph for positive values of x. Okay, so we just graph 1, 2, and 3. I think that's it, right? Okay, so first we need our points. So y, this is for the graphing, is equal to 2 raised to x plus 1. So if x, we know that x is 0, we'll get this, right? And then so I'll just need 1 and 2. So x is 1, y is 4. Okay, is that clear? All right, so let me just write it. So 2 raised to 1 plus 1. So that's 2 squared, that gives us 4. Then if x is equal to 2, y is equal to 2 raised to 2 plus 1, so it's 2 cubed, so it's 8. So those are your points, 2, 4, and 8. Okay. Okay, so let's try to draw now. Oops. Okay, so let's try drawing this thing now. So we have x as 1, 2, 0, 1, and 2. So let me put this 1, and then this is my 2. And then for my y values, okay, so let's see if it's a 1. Okay, so it is 8. Okay. And again, this is x, and this is your y value. Okay, so let's plot those points now. Okay, so we have 0 and 2. Okay, and then 1 and 4. And then 2 and 8. Okay. So class, do you have any question on how we got the points, class? No. No? Okay. All right, so this is your curve, class. So we just, again, this is a curve because this is an exponential one, okay? If you're going to draw your curve, it will look like that, okay? Wait, maybe you just need to curve this more a little bit, okay? So something like that. So this is your answer for number 6, okay? And so it goes up now. Okay. So do you have any question with number 6? None? Right. All right, how about number 14, class? Okay, so can you please do this first? Maybe I'll give you 2 minutes. So find the value of x for which y is equal to e raised to x minus 2x minus 1 and has a minimum value, and calculate this minimum value. So how do we compute for this? How do we answer this kind of question? Mhm. All right, number 14. Try to answer this. Okay, so again, if you're given this kind of question, so you're given this function, and then if we say minimum value, it has something to do with the gradient, right? So the gradient of the curve. So what do we need to do here? So of course, we need to get the first derivative, right? So how do we do that? So we have d1 is equal to, okay, so what's the derivative of e raised to x? That make, what's the derivative of this? It's the same thing, right? It's still e raised to x. And then minus 2. So that is your first derivative. Okay. So again, if this minimum point, so we need to find the value of x equals 0. Okay, and then solving for x here. How do we solve for this kind of question? Anyone, how do we answer this? Class, you remember your logarithms? Okay, so to answer this, so we need to put, okay, we need to put natural log or ln to both, right? So it becomes ln of e raised to x equals ln of 2, okay? So by law of logarithms, this x here will become, a constant, coefficient here, right? So it becomes x and then ln of e equals ln of 2. Okay, so in this case, this is not equal to 1, right? If you check our calculators, so that's equal to 1. So basically, we only have x. So x is equal to ln of 2, or in your calculator, what is that? Okay, so that is 0.693. Okay, so that's your x value. Okay, so do you have any question, Sec 4 class? All right, so if this is our x value, so what is the minimum value? Okay. Okay, so let's get our second derivative. So how do we get our second derivative for this kind of question? So it's the same, right? It's still e, right? Okay, so it's still e, so d squared over y over dx squared is equal to, so how do you derive that? So it's just e raised to x, okay? And then plugging, so when x is equal to 0.693, your answer is, so we plug it there. So what's your final answer? Plus, you need your calculators on this one. Okay, so your answer is 1.99 or 2. Okay. Again, since our answer is a positive, that means, yeah, it is a minimum. Okay, so yeah. So this is your answer for number 14. Class, you might forget about this, or maybe have forgotten about this. So in order for us to solve for x, when we're given this kind of question, we take in, we put ln or ln in both sides, okay? Because ln of e is equal to 1, and we want to remove that, okay, that e. So again, after we plug in ln, or we put in ln, so x here will be multiplied from loss of probability, loss of logarithms. And then so we have x here. So ln of e becomes 1 now. So that's basically, yeah, so just x. And then ln of 2. So solving for that, you get 0.693. And then for your second step, because it's asking for the minimum value, so the minimum value is 2. Okay, so it's a positive, therefore, yeah, it's a minimum value. So that's for number 14. So class, do you have any questions? None? No questions, set 4. Okay, if there's no question, I think.